Good to be with you. Well-attended conference. I guess you're at like 98% attendance, which is truly remarkable. I'm kind of on the lecture circuit, and I don't see numbers like that, even at conferences like on infrastructure that I just came from yesterday. Happy to share some overview remarks about the groundwater state of play in the United States, and with specific emphasis, obviously, on Colorado, the headwater state that you're finding yourselves in this morning. Let me advance to this water stress tool, that the aqueduct tool that the World Resources Institute puts out every couple of months. They update this thing, and it shows water basins by stress level, and globally, two of those are in our state. The Rio Grande and the Colorado River are 14 and 16 of the top 18 by water stress in the world, and so we really have a small population in the state of Colorado, 5.4 million people. Compare that to California's 38.5 million. And you can see we're pretty small population-wise. But when it comes to water, 18 downstream states in the country of Mexico depend on water that starts here. And so we punch above our weight. And so it's good that you're here. Really appreciate the School of Mines' continued emphasis on water and hydrogeology and all the stuff that comes out of this fine institution. Really makes our state able to lead on water policy because we have the scientists here. So that's really a great attribute of our state. So a quick historic overview. Science of groundwater hydrology. I know you guys have forgotten more last night than I'm ever going to know about this stuff. So I'm going to give you just an opportunity here to think back, or to step back, I guess, and contextualize what it is you do. The science of groundwater hydrology has only been around for about 150 years, as you know it. And it's really taken the last 2,000 years for us to develop the very basic fundamental things that you all, I'm sure, take for granted and peel the onion back on every day. Those basic concepts: groundwater comes from the surface. Geology tells you a lot about where your groundwater sources are, what the aquifer looks like. And the third principle that I've read, movement of groundwater obeys certain physical laws. Believe it or not, it wasn't very long ago where that was not viewed as a given. That was not something that people, the Greeks thought that there were these rivers that were underground, and they didn't see any connection with rainfall or the surface in those rivers. And so we're, relatively speaking, especially in geologic time that you all probably work with, relatively speaking, we're really new to this science, and we're trying to make sure that our policy is updated as quickly as possible, knowing that our policy moves fairly glacially in water. We in Colorado joke about water time. If a water project is moving forward, you're talking about decades, not years, and certainly not months. So our policy is something that we've got to make sure is updating along with the science. Size and magnitude from the USGS on this stuff. Again, stepping back, and these are numbers that you probably all knew at one point, but have maybe not looked at in recent memory. 101. We all, in the surface water business, we work in acre feet. That's our volume amount or unit of measurement. In groundwater, you probably use gallons. The USGS used cubic miles, and I had to do some conversions, or Google did some conversions for me, and I came up with there are 101,376,000,000 acre feet in all the world's surface water storage, natural lakes and reservoirs, all that surface water storage. 101 billion acre feet. You can add in about 1 billion acre feet in terms of water in streams globally at any one time. And storage and underground water is 30 times those numbers. So it's like 3 trillion acre feet, which is a really amazing number when you are used to, in my business, dealing with, if you're lucky, millions of acre feet, and more likely you're dealing with hundreds of acre feet. And I'll get into that a little bit more here in a second, but the USGS Aquifer Map that you have all seen a million times, it's probably tattooed in your memory right now. We're going to look at that, and that's really nice. And it looks like there are these nice, neat lines around these aquifers around the country, or certainly around the West. And there are, those are lines of demarcation that are pretty pronounced. But we're all connected by surface hydrology, law, policy, politics, and economics. And so I'm going to start there with that story. In the Front Range area here that you said, I'm going to tie you to the Bay Area in California through the surface water politics and law that have grown up around the Colorado River, which, as you probably know, 243,000 square miles, 33 million people depend on this river. If you just took the GDP, the economic numbers for this basin, it would be the 5th largest economy in the world. So it's no slouch. It's really an engine for the southwestern part of the country, and certainly in agriculture and in other businesses. And when you look at Southern California, you've got a lot of dependency on the Colorado River. So how are you tied to it? A little blue arrow should pop up there. It is. Rough justice, we have the wet side of the state on the western slope of Colorado, where I'm originally from, and then we're sitting here on the Front Range, and we move about 500,000 acre feet of water a year from the wet side of our state to the dry side, the more populated side, and I'll show you that in more detail here in a little bit. But that's step one. So that gets you to the Colorado River. Colorado River cuts through 7 states, goes down to Mexico, and we have a bunch of out-of-basin diversions, including the California aqueduct that takes water across Southern California into the Southern California area and past some irrigation districts that are of size there. If you eat a strawberry or a lettuce in February, you're probably getting it from that Imperial Valley down there. And then the State Water Project really connects you and people in this room and Coloradans in general to the Bay Delta, because the source of supply for Southern California is really threefold, and it's the Bay Delta, wet part of the state in the north in California, populated part of the state in the south. They have that State Water Project that moves water north to south. And then they have desalination with the Carlsbad Project in San Diego that just opened up. So that's a small amount of water that expands, I guess, or diversifies their portfolio down there. And then you've got Colorado River supply. And NASA's Jet Propulsion Laboratory did a study a little bit ago, about a year or two ago, that talked about groundwater, at least in the lower basin. And they unfortunately generalized, and if anybody from JPL's here, I apologize, and I'll talk to you later. But they really overgeneralized. They used 3 nodes is all in the upper basin, and they used those 3 nodes to suggest that there is this massive amount of groundwater in the upper basin of the Colorado River. And that may be true, it may be false, but the 3 nodes were not sufficient enough as a scientific basis for some of the claims that they were making. In the lower basin, much better, a lot more data points that they used for groundwater assessment down there. And I think at least the engineers in my office were a lot more comfortable with JPL's lower basin numbers than they were with their upper basin numbers. But in any event, we have this system that ties us together. And like I said, this is mostly surface water related, but it really does mean that anything that happens up here in Colorado or the rest of the state or in the Bay Area it really impacts everybody else in these systems. And the dynamic in the upper basin and the lower basin is that we used to have if you go back to when the compact that divvied up this water, the surface water, was signed, we had 18 million acre feet. That's the lime green shading there. 18 million acre feet of water on average to work with. And now, in the last 15-year period of record, we've had 12 million acre feet, if that. It's the worst 15-year period of drought, if you want to call it drought. I don't like calling it drought because if you call it drought, then hope is a strategy, and that's not good. So it's probably the new normal. 12 million acre feet is substantially less, obviously, than they thought was available in the system when they started carving it up legally. And so we are in a period of trying to figure out as states, the 7 states and the country of Mexico, how to share shortages, how to maintain elevations in Lake Powell and Lake Mead. And I can talk more about that later, but this is a groundwater conference. Ambient air temperature, I have to always put this in my slide decks because I'm usually talking to people I'm related to over on the Western Slope who are not real fond of the climate change word. And I tell them, I don't care if you're Republican, Democrat, Independent, our air temperatures have warmed by 2 degrees in the last 30 years, and that's not disputable. So that's our reservoir. You guys know. And by the way, if you ask pick your most conservative rancher and ask them about the high water runoff, when is the peak runoff on their system, and they'll tell you, well, it's two weeks later sorry, 2 weeks earlier than it used to be, and that's that's not disputed either. But here's the map you've all paid money to see. This is these are the aquifers around the country. And you can tell, obviously, they don't respect state lines. In fact, there's like a blatant disregard for political boundaries on the map there. We have this patchwork that you'd think we would have a lot more interstate compacts like we have for the surface water. In Colorado alone, and because we're the headwater state, we have a lot of these. We have 9 interstate compacts, 2 equitable apportionment decrees. Nationwide, there's not a single compact on groundwater. And we can talk a little bit about that, and that's a little bit of a spoiler, I guess. I should have given you a spoiler alert, because that's my conclusion, is that we're heading rapidly in the direction on a policy front of having interstate compacts for groundwater aquifers, especially in the High Plains Aquifer, because it underlies so many states, and there is rampant development and pumping going on in different pockets of that aquifer. But since I just stole my own punchline, I'll go to the more boring walkthrough. This is a more boring map because it's a policy map of really how groundwater is treated legally and at a policy level around the country. And you see some different categories here. Absolute ownership. This is like the dark ages. This is the English common law. This is what we brought over back when we were settling the country, and the colonies still have. You can see Massachusetts, a lot of New England, and Indiana, Texas, Louisiana. They're still kind of trapped in this. This is the right of capture, right? So it just says if you own the property, you can just drill down, take what you want. Doesn't matter if you injure somebody else. Go for it. So it's kind of, I guess it's kind of fitting. It's kind of the Wild West, and Texas is still doing it that way. Then you've got, let's see, the next one down there, absolute or reasonable use. That's the light pink, and that's really only a couple of states, maybe just Georgia at this point. But most states transition to that reasonable use doctrine, and then you've got the lime green up there. They looked at this kind of Wild West absolute ownership thing, right of capture, and they said that's arcane and it's not humane. And so what we'll do is we'll put in a system of reasonableness. Well, what's reasonable? Lawyers love that term because that means you can just kind of argue about what reasonableness is, and you can bill hours when you do that. So that's a good thing. But you can withdraw water generally if it's reasonable. You're liable for unreasonable use. The only So that means what's unreasonable? Uh, if if it's a qualified, this is a qualified right, not an absolute right, like the absolute ownership. Um, so we kind of say no interference is what we mean by reasonableness. So if you've got a cone of depression right underneath your feet that you've created, and somebody else is pumping out of the same aquifer, creating their own cone of depression, and it overlaps with yours as the surface right owner, you are injured, and that is interference, and that means that the other user is being unreasonable. And so that's kind of the legal regime, really broad brush here, talking about reasonable use. So a lot of the country went in that direction, and that kind of stems. They call that the internationally the American rule. That's what, if you've heard that reference, it's from a New Hampshire case back in 1862 that kind of spawned that. So going down to the next legalistic one is a restatement of torts, section 898. That is, or 858, that's the English American kind of combo that basically said, well, if groundwater is still owned by the landowner, which, we're going to let that happen. Got 5 minutes? Holy smokes. I'm going to have to hustle. Okay. So this is all boring as heck. So I'm going to go to Colorado. All right. This is our state, 5.4 million people, second fastest growing state in the union. Let's see, North Dakota is the only faster growing state than us. A headwater state, 18 downstream states, country of Mexico, 10 to 14 million acre feet of water fall on our state every year. But because we can't just use it all here, and we have to let some of it go down to the other states pursuant to a Supreme Court decision back in the 1900s, we have to share it. And we do that with 9 interstate compacts, 2 equitable apportionment decrees. And so we're tied to these larger systems. This is the state of Colorado. It really represents that dynamic I was telling you about earlier, with 80% of our precipitation on the west side of the Continental Divide, 90% of our population is on the east side of the Continental Divide. So that's why we move 500 to 600,000 acre feet every year from the left side to the right side. This is a depiction of all the loans that we have out in different water projects around the state. And I can tell you very, very few, if any, of these are specifically groundwater projects. The governor that was referenced before, Governor Hickenlooper, when we've talked about storage, which is a key part of Colorado's water plan, he wants us to really roll up our sleeves, get together with you guys, the scientists on this stuff, and figure out what we can do in terms of groundwater storage around the state of Colorado. We have the Denver Basin Aquifer. That's a little bit better map. And we did a quick study of this about 10 years, well, it's about 8 years ago now, that said, let's identify where the best places for groundwater recharge might be. And we identified some of these designated basins around the state. These are non-tributary basins, and we want to make sure that we're putting as much underground as we possibly can, if the technology will allow us to essentially do an MRI for the ground. That's what we're trying to do. That's what you guys work on, and you can tell me if we're close enough to being able to allow the predictability of taking acre feet out that we put in. This is our water plan. We didn't have one of these prior to 2015. The governor said we need to make sure we're addressing this water supply demand gap. That's the measurable objective wheel. Supply and demand is up there at the top. We're supposed to be out of whack by 2050, about 560,000 acre feet out of whack, where supply and demand curves have crossed. And that has resulted in us needing to address that. And we've got to hit it from the supply side and the demand side. From the supply side, that's storage. And the governor's insistent on us looking first at groundwater, underground storage, and then also expansion of existing reservoirs before we look at new reservoirs. So that's the 560,000 acre foot number. We have the statewide water supply initiative that we're updating this year, and we need to do a better job at looking at groundwater capability. So we're doing some studies on that, and I'm sure we'll be in touch. If you're interested in that work, please email me, and we'll get in touch, and I'll put you in touch with Andy Moore, who's our resident expert on that. And all this stuff's going to take money, which I won't bore you with. But the storage part of this is 400,000 acre feet of new storage needs to be online by 2050 in order for us to zero out this gap that I was talking about. And we can do it if we also have, on the demand side, 400,000 acre feet and additional conservation. So we need to hit it with 400,000 acre feet from both sides of that equation. The South Platte, as you saw from those other maps, is really our Gordian knot. If you can untie that thing, then all the other pressure from around the other basins in the state is alleviated to a large extent. And so the South Platte has become the center of the focus of these groundwater studies that we're undertaking as we speak. This is the money stuff, boring, and with that, I think I am done with my time, Cassandra. So I will take any questions.